Okay, so I have a really cool set of papers here. Eva wrote them. They're very straightforward, very simple, and they express ideas in a way everybody can understand. The first one is model for solar system formation. Extrapolation, it's the same idea that is common knowledge among astronomers. A planet can capture a moon. We know this. A star can capture a planet. That's the unknown thing. And then he says here, astronomers have a problem with it because of the rate of encounter in which stars meet planets in the universe. But if you look at Sirius A and Sirius B, it should read, one star can capture another star. So capturing planets could be widespread. And we know stars capture other stars because they're binary systems, they're tertiary systems, they're quad systems. There are stars orbiting stars all over the place. If stars can capture other stars, stars can easily capture lots and lots of planets. And that's exactly what happens. That's how the solar system's formed, is that the sun captured all the objects. Now, we don't know if the objects that the sun captured first are still here, nor do we know their orientations when the sun captured them, if they settled into an orbit after the fact, after the sun captured them and they settled in after everything is calmed down. But basically, that's how solar systems are formed. Evo's completely correct. It's adoption and rejection. The adoption part happens when the large object is born, travels through the galaxy, orbits the galaxy, and picks up objects on its way through the galaxy. And sometimes it picks up objects that are really large, which have objects already orbiting them, such as Jupiter or Saturn, or maybe even the Earth, with Earth and its moon. So basically what it could mean is that Earth and the moon have been together longer than the sun has even been the sun. I wrote that in another paper, but I don't want to go over that. This is more, it's Evo's ideas here are more important. And that's very interesting to understand. Is it's like there's a big thing capturing another big thing, and then a small thing capturing other smaller things. But then astronomers just miss the middle ground. And the reason why they do that is because they want the nebula hypothesis to be correct. They want everything to form from a big dust cloud, which doesn't make any sense at all. And Evo goes over that in the other paper. I'll link these two papers to the bottom. Disproof of the accretion model. Gravity in outer space is neglectable to form any clumping of material. You can falsify this accretion model yourself. Take a pen and drop it on the desk in front of you. How does the pen clump to the desk? It probably won't. I mean, it might rest on top, but if you take the pen and you drop it on the edge of the desk, it's going to fly right off. Be aware that the Earth's entire gravity is pulling on the pen towards the desk. The entire Earth is pulling on that pen, and it still can't make it clump together to the desk. That says a lot about gravitation. How can a small piece of dust in outer space clump gravitationally wise to another piece of dust when there's virtually no gravity? That's another very important aspect of the accretion model of establishment. They have planets forming absent a gravitational field already being there. So they say, well, the dust is there, therefore it has a large gravitational field. No, you just can't put gravitational fields wherever you want them to be. You need a very large mass to already be there to give orientation for that dust to clump in. If there isn't anything to orient the dust in outer space or the gas, nothing's going to happen. And we know this because we see nothing happens inside of large nebulas where there's huge amounts of dust and nothing's happening. They're stellar graveyards, if you will. Another two very important parts here that he goes over. There is a variation in the speed and direction vectors of objects in a solar system that does not substantiate an accretion model. Number two, variation in elemental composition of objects in the solar system does not substantiate the accretion model. If dust from a supernova, or even multiple supernovas, would accrete, you would expect similar composition of objects if they formed out of the same dust cloud. All objects in our solar system are very different in composition. We're not living on the sun here. And that's also very important. You have objects moving to and fro and all over the place in retrograde orbits. Some objects in Jupiter are in retrograde. Neptune and Uranus, their axes of the way they're oriented when they're in their orbit is weird. I think Uranus is like a 89-degree tilt or something like that. How did it get like that? How do you explain the weirdness of that by dust clumping together? It doesn't make any sense. As well, if it all came from the same dust cloud, why are the objects all different? Why is all that hydrogen in Jupiter? Why is Pluto, the rocky object that's smaller than the moon, billions of miles away from the sun? You know, how do these people think that somehow all this came from a single dust cloud when they're all different in composition? That being said, thank you, Evo, for writing in this paper. The adoptive family is very important. You got to look at the solar system as being a bunch of objects that all came together at varying times, and they all have different evolutionary paths, and they're all different ages. And plus, I got something really cool I want to show you guys. I had bought some meteorites. That's really cool. These are legit Capodiceo meteorites. This one's about 27 grams. And then the really large one, that one's about 220 grams. So this one is I'd say about 10 times the size of this one. And this is going to seem really ridiculous, but like Evo's pin to the table analogy, you can't clump things together with gravity alone in outer space. And I can prove it. Check it out. These are two legit meteorites that came from outer space. Establishment dogma wants you to believe that these two things just hitting each other at any appreciable speed can cause them to clump together. Check it out. Even when they move really, really slowly, they should be able to clump together. Now, let's see if the dogma is correct. Don't hold your breath. That's what's going to happen in outer space. If you have a bunch of these objects in outer space, they're never going to clump together to form a planet. You need something that's really hot, really big, and has a strong gravitational field to pull the material in together. That's what stars do, because stars are the objects that form the planets. They are the same things, essentially. The stars are the nebular clouds that collapse upon themselves and form the round, rocky objects that we're walking on every single day. All right, you guys, later.